Okay, good morning. Today I thought we'd review process for the project development. This is a good process for any form of software development. And let's figure out where we are and where we're going here. We're in week 7. And next week we'll talk about, that works. Next week we'll talk about the Java FX controls. So how to get the GUI to talk to the model. And then after that, we'll get into exception handling and file IO. The last topic really is abstract classes and interfaces. And after that, the rest of this course from November on is the material's optional. So there's some extra credit opportunities there, but there's no required activities there. So the idea is you get more free time to work on the project and to work on the remaining homeworks. Normally what I do when this is a face-to-face class is we actually use the class time for people to ask questions about their code, and I'm fine doing that also. So I'll probably do what the Friday's lecture will definitely be about people asking questions about their code. And if we can have it where that's both Wednesday and Friday, that would work out well too. So that's going to be my goal. Upcoming due dates. The P3 is on 21 October, but I'll have a peer review exercise prior to that. And so that will probably be due on either Sunday the 16th or Monday the 19th. But Monday the 19th probably makes more sense. The idea behind the peer review exercise is I'll organize you guys into pairs and or groups, and you share your P3 deliverable with someone, and then they make comments on it and give it back to you. And so what I wanted to do today is talk about process and also talk about what kinds of comments you might make. And next Friday, we'll continue that discussion. How can you look through these things and find mistakes in other people's deliverables, which is also teaching you to help find mistakes in your own deliverables. Mistakes and or just, let's say, suboptimal phrasing. So again, let's go through this process one more time. That's not right. So basically, you should understand what the process is that I'm asking you to do and then apply it to your project. The basic process, and this is loosely based on Agile Scrum. When you take SE300, you'll follow that process more formally. As you take other courses that require software development, you'll follow that process more closely. So the steps are, you create this overarching vision of the end product. It's not in super detail yet. It's just a clear vision of what the product is. And you did that in your P1 deliverable. And then you start to break down in more detail what the actual functionality is of the project. When I say functionality, I mean, what does this thing actually do? When you call a method, what specific thing does that method do? Now that at this point, At this point, you don't know what the method is. You just know that the product needs to do something, right? So the product needs to have some kind of behavior. And then you did that in P2. And then which by the way, I'm still grading, so they do take some time to grade. I do try to give feedback. If you feel like I didn't give you sufficient feedback, you can always follow up with me. And then you create the initial design for the product. And that's what you're doing now in the P3 deliverable. So once you have this notion of, okay, now I know what this thing needs to do, you've got enough information to say, okay, here's how I think it can be structured. Here's the objects and classes that I need. And requirements, create the requirements in the test cases, which is also what you're doing in P3. Now in a commercial setting, in a professional setting, you're going to create far more requirements that I'm asking you to do here, and you're going to create far more test cases that I'm asking you to do here. But this is just getting your feet wet, giving you a sense of what it takes to build a requirement and to build test cases for it. And then you start, once you do that, only then do you start implementing the code. And you do that in 4 sprints. That's what the P4, P5, P6, and P7 deliverables are. P4, 5, and 6 are code drops only. I'm sorry, I shouldn't say that. It's not the, you don't include the software design document, and you don't include the requirements and test document, but you do include all of your software and the agile tracking sheet updated to show, okay, here's the user stories I completed. Here's the time that I've spent so far. Here's the time that I think I need to spend still to get this thing completed. So questions about the phases that I'm asking you to do. Notice how long you go before you start to actually code. The biggest mistake everybody makes, and I don't mean just students, I mean everybody, is they start coding too early. Okay, so if I use the ubiquitous sheepdog game as an example, my overarching vision, a human player plays the role of a sheepdog trying to get 3 sheep into a pen, and the game score is scored in seconds, and the low score is better. The low score wins. And so we have this rough visualization of what that game is. Now, were I to actually fill out a P1 for this, then I would have a little bit more verbiage than that. And in the P2, I can talk about, if you've ever seen actual sheepdog trials, this is effectively the same as a sheepdog trial, where I would talk about, okay, here's a real world event, and describe it, and then talk about the computer version of that. Talking about how the user controls the dog, and then the sheep are not controlled by the user, but they're going to have behaviors where basically they're always trying to get away from the dog. Then we describe the functionality in detail, and that's your P2 deliverable, so you've already done this. And the question you really want to ask is this. If you wrote your P2, right, go back and look at your P2, and then give it to somebody and say, okay, you have to write the code. I'm not writing the code, you are. Did you give them enough information that the code they created was actually something that matches your vision? Are they really going to create the thing that you thought of? Now, that doesn't mean that all their design decisions are the same. You're going to do a dungeon crawler, and you thought all the dungeons should be gray, and they think the dungeon should be pink. Well, that's a design decision. But in terms of functionality, in terms of, okay, there's trapdoors, and there's monsters to fight, and there's weapons to pick up, and here's what each weapon does and doesn't do. That kind of question. So if you're thinking, okay, I can pick up a sword, or I can pick up a potion, and the potion is a ranged weapon in terms of role-playing game terminology. So the potion allows me to attack at a distance, and the sword doesn't. And then, they design in a way where it's complete opposite. The potion has to be physically poured on the entity that you're attacking, and the sword can magically inflict damage at a distance. That violates your vision. So the idea is that, that's a good check for yourself. How much detail do I need? You need that much detail. From there, once you have that overall description of the functionality, then you start to write the user stories. And what the user stories are doing are they're taking the functionality and breaking it into bite-sized pieces. And again, you've already done that. A lot of the user stories that I'm seeing are good, by the way. I should have a. Oh, there it is. Yeah, the user stories provide both priority and an effort estimate in hours. So, okay, in order to do this, I need 6 hours. In order to do this, I need 4 hours. And hopefully they're, again, it's manageable, small bite-sized chunks. If you have a user story and you're saying this is going to take 40 hours to do, what you probably have is 3 or 4 user stories. Again, in the context of this class. When you get into more sophisticated pieces of software, it may be entirely legitimate to have a 40-hour user story. But that's when you're working on the, in a commercial environment, in a professional environment, where your only job is for 8 hours a day to work on that software, as opposed to the academic environment where you're taking 3 or 4 other classes. And I'm not assuming that you're going to work 8 hours a day on this class every day. So we scale everything down in terms of effort, but the structure is there, the process is there. Then you create an initial design. You've worked with the idea of the functionality long enough. You've worked with the idea of the user stories long enough that you can start to say, okay, here are the objects that I think I need. And you start asking yourself that question. In order to get this job done, what objects do I need? What classes do I need to define? The ones that are physical objects are the easiest to figure out. Oh, okay, I need some sheep and I need a dog. It's pretty straightforward. And we talked about this in the lecture last week, I think. Then you start to think of non-physical things. Oh, wait, I need actually something that will run the game. Again, in a role-playing game, that corresponds to a physical object called the dungeon master, right? So you have somebody who's running the game. Well, here you have an object running the game, or maybe several objects working together running the game. And then you might have some special purpose objects. If you're doing some kind of a simulation and you need to do some analytical processes, you can create a class just for a specific process. Some of you guys are doing the elevator studies where you're doing statistics. Not a bad idea to have a class that just does statistics on the data. If you're worried about running into things, you can have collision detectors you can either embed that functionality in the objects themselves, but if you say, let's see, I've got a racing game and there's a race car and there's walls on the race and the car isn't allowed to hit the car shouldn't hit the wall. Well, does that functionality belong to the car or does it belong to the wall? Or does it belong to the game controller? And the answer is, since both the car and the wall are involved, and you probably have separate classes for the car and for the wall, and this action involves both of them, you might want to put it up at the game controller level. And then you could say, well, I don't want to embed it in the game controller. I'm going to have a separate collision detector class. That's its job. And the game controller can build an object of that class and then ask the game controller, ask the collision detector, hey, did anybody run into the wall? So you can start to think of these special purpose objects also. And again, I stress, don't think you're going to throw this together in a half an hour. Put some thought into it. The more thought you put into it now, the better your programming will go. So by spending some time here in October, you will have a much happier November. Once you've decided what objects you need, and this is iterative, by the way, you're gonna change your mind. That's fine. Then you say, okay, what attributes does each object need? What do I need to keep track of? What does that object need to keep track of in order to do its job? What does that object need in order to describe its state? If somebody asked, what is the state of that object? Then what attributes do you need to keep track of? So for example, if I asked you what the state of your car was, okay, it's in park, the engine's off, the doors are locked or unlocked. You probably need attributes for that. Oh, it's at this location. You probably need attributes for that. Then you get down into the ones that you may or may not need. Its tire pressure on each tire is an average of 32 PSI. Well, you probably don't need to know that. So that's probably not material to what you're doing. It might be, but it may not be, right? So you make that decision. And if it isn't, then you don't worry about it. Oh, its color is gray. Okay, that may not be something that's of any value to keep track of. The radio station is tuned to 90.7. That that may not be something to keep track of. You have to sort through what is necessary in the context of your specific project. What do you need to keep track of? You've got a player that can pick up weapons. You probably need to keep track of what weapons they have. And if they can have more than one, that's probably an array of weapons, not a single primitive attribute. And then other than what does it need to do to describe its state, what does it need to do its job? So sometimes you'll need additional attributes that you never need to share with the external world, but in order for the object to do its job, in order for the object to do all of its functions, maybe it's a helpful attribute to have. And then you go through and do the same thing with the methods. And the methods, this question for the methods tends to be harder than the attributes. But basically, what objects does this thing perform? And what other classes are going to ask this object to do? Usually what other classes ask is for information. So, your setters and getters. But sometimes classes will ask, the other classes will ask that class to do a job. For example, the collision detector, right? Hey, I'm going to give you two entities and you tell me if they just collided. That's your job. Or for the analytical processes, I want you to give me some kind of a statistical summary of all this data. I need to know the mean, and I need to know the standard of deviation. So a lot of this is you in your head thinking through, how is a user going to use this? In order for the user to use this, what do these classes need to do, and how are they going to interact with each other? This initial design does not have to be, you're not on the hook to be 100% correct. But again, you are on the hook, in my opinion, to do an honest job of it, to try to get this nailed down in as much detail as possible. We're not good as humans as always thinking in this level of detail until we do it a few times. And a lot of engineering, I think, is about that, thinking about detail, thinking about what can go wrong, what happens if I make this decision. And that especially true, I think, in software engineering. Then you create your initial design. So I'm just recopying this UML diagram that we talked about the other day. And now you've got a good basis to do your coding. You can start coding these classes up, and since you're going to focus on one small aspect at a time, you can be very productive because you're not going to get distracted by things that have to happen in other parts of the code. Then create your requirements and tests. Now, as I've mentioned before, outside of this class, there's different ways to do this. One is that you wait until you pick your user cases, and as you're actually performing those user cases, you create requirements and test cases just for those user cases. But another form is to create all the requirements and test cases up front. And I don't know that there's a single best way to do it. In this class, I'm asking you to do them up front. And one reason I'm asking you to do that is because you're not making requirements and tests for your entire project. You're making 5 requirements, 3 test cases per requirement. So it's a sampling. Your requirements should be atomic, attack one small behavior. They should be unambiguous, concrete language, formulas, units. You can't say that it has to behave correctly, because I don't know what correctly means. And again, the project only requires five requirements. A real project may have hundreds of requirements. And then multiple test cases per requirement. I'm asking you for 3. Really, the number of test cases that's appropriate for a specific requirement is however many it takes to fully test the requirement. And that often gets to be 1, 2, 3, 4, about 7 is a minimum based on bad condition low, good condition, bad condition high, and all the boundary conditions. Your test cases should be concrete, specific as possible. Again, ask yourself, if I were to hand this document to 5 random people, would they all perform the exact same test using the exact same numbers, the exact same inputs? And if the answer is no, it's not a good test case. Also, students tend to really focus on their code working. And as engineers, we really need to engineer to protect ourselves against failure. So you can test conditions in the real world. You would test and say, okay, here's where if a method got this input, it will blow up, right? It will cause an error. And then in the real world, you write some exception handling routines to handle that. And then your actual test behavior would be, given this input, this is the expected exception handling behavior. In this class, I'm not requiring you to do exception handling everywhere. So it's okay to have a test case where you say, given this input, what's the result that I expect? I expect my program to crash. I expect to see fatal error. And if that's what happens during the test, that's a passed test because it behaved as you expected it to, as you designed it to. And then lastly, once you have all this down, then you start to implement the code. In this class, we're doing 4 sprints. Now, again, sprint is a agile Scrum terminology. A sprint is a short piece of time where you do this small amount of work. So you've got 12 user stories, you've got 4 sprints. So on average, you're going to do 3 user stories per sprint. Each sprint averages 12 days. So the P4, P5, P6, and P7, it's 10, 11, 12, and 14 days each. It just happened to work out that way. So again, imagine for P4, you're going to turn in your P3 deliverable, and then you've got 10 days to turn in code for P4. And you have to think, okay, how many hours do I honestly have to work on this over those 10 days? I can scrape up 10 hours of work. So go through your user stories and start with the highest priority one, and then the next one and the next one, and basically go until you've got 10 hours worth of user stories. Oh, and by the way, if your estimates on all your user stories are 160 hours, well, that's 40 hours per sprint. That's telling you something, right? That's telling you that maybe you're trying to do too much, or maybe you've just super overestimated your hours. As a general rule, students underestimate. So I'm seeing some where people are thinking they're going to do their project in about 20 hours or 26 hours. And I'm suspicious about that. I would think that it's going to be longer than that. How do you know how long it's going to take? Well, that's what experience is for. After you do this effort in this class, when you go to SC300 and they ask you to do it again, you're going to have experience. You're going to say, oh, I did something like that before and it took me 4 hours, or I did something like that before and it took me 12 hours. So then you'll have a better idea. And the idea over time is you get a really good sense of your own personal code productivity. Okay, I think, I'm a slow coder. That's me. I am a slow coder. In order to do anything, even simple stuff, it takes 4 hours. I get wrapped up in trying to make my GUI look too pretty, right? So, okay, to do a GUI for me is a 16-hour job, even if it's simple, just because I'm going to keep moving buttons around like an idiot. At the end of each sprint, you have functioning code. Now, my recommendation, and I noticed several people followed that in user stories, is to take your UML diagram and code everything out. Right, code out every method with all the classes, but all the methods are empty. They do the dummy methods that I've been showing you in the class examples. Instead of returning a real value, they return -1, and then they also print out, you know, this is not an actual value. This method was called, but it has not yet been defined. Dummy value used. If you get that far, you've got functioning code. Now, ideally, what you want is functioning code that actually performs at least one meaningful function, right? You've got at least one user story down. So you've got functioning code that actually, maybe all it does in my sheepdog game, maybe all it does is it shows the dog. I can't move the dog, but it's on the screen. Or maybe I've got to the point where I can move the dog. I don't have any sheep yet, but I can move the dog. You look at the user stories, and each one, then by the time you're done with a sprint, you've got functioning code. Then in the next round, you have, you know, in the next sprint, you add to that functionality. So maybe after the end of 2 sprints, I'll have a dog that runs around, and I've got sheep that run around, but they don't really react to the dog properly. And in the 3rd sprint, I've got a dog running around, the sheep run around properly, but I can't put them in a pen yet. And then the 4th one, once they go into the pen, then they stay penned. You know, look through your user stories. At the end of every sprint, you're going to turn in all your code. A single zipped file is the best way to go. And also that sprint planning sheet, the agile tracking sheet. And we'll have code reviews. So from now on, before you turn something in, both P3, 4, 5, 6, 3, 4, 5, and 6, but not 7, we'll do a peer review before. So you're going to give your code to somebody, or you're going to show it to somebody in a Zoom meeting, and they're going to sign off that you've what you have and haven't achieved. And then afterwards, of course, for the grader. Now, again, in a face-to-face class, what I do, I literally require that you go to class and you show me your code in class, and you tell me, okay, here's user story 1, 2, and 3, and look at my code. It does 1, 2, and 3. Or here's user story 1, 2, and 3. Here's my code. It does 1 and 2, but it doesn't do 3. Showing the code, demonstrating it. So I want to work out a way where we can do that online, and I'm quite frankly a little baffled as to how to do that right now. What may be happening, since since I'm thinking the lectures will be tailing off, and even these Friday lectures will be tailing off, the idea is we can use those days for people to show me code. What I'm a little concerned about is people may not want to show their code publicly if there are multiple people in the room. And so we might find ways to work around that. maybe use the breakout room facility. Although we'll have to experiment with that. If you have wonderful ideas on how to do this, by the way, then let me know. One way that we could do peer review, by the way, if you're willing to show your code in class and have people look at it and talk about it, then I would count that as your peer review. Okay, do we have questions before we go on to examples? Okay. Let's go with the, here's an example from a semester a long time ago. And these are requirements. So here's a requirement. Simulation shall terminate when total healthy people reaches 0. I think we talked about this one before in terms of test cases. This was a zombie chase game. Simulation shall terminate when total healthy people reaches 0. What, do you like that requirement? Is that an okay requirement? Can we test that requirement? Can we cheat that requirement?
Yeah, seems good.
That looks pretty good. Now, I would argue this bulletized form, don't do that. Remember, traceability of requirements, right? So traceability means that we have a number for every requirement, and we can figure out what user story drove that requirement, and we can also figure out what test case is testing that requirement. And ideally in the code, you document, how where that requirement gets met in the code. You would do that in your requirements and test document or in the software design document. But the main thing here is don't do the bulletized listing, number them. This seems pretty good. I think we can do that. And what test cases would we have? We would have test cases where we would have, and again, don't think about it as the user actually running the code. You can write your own methods just to run test cases. So why not have a method that injects a positive value for healthy people, 1, and then show that the loop that is running the simulation goes through one more time. Or that if you have maybe a method that where the termination occurs, that the execution, the line that executes the termination of the program was not executed. And then you would have another test case where you would just inject the value of, somewhere there's an attribute for healthy people, right? And so you inject the attribute value of 0 and you verify that the simulation terminated. And then put in a negative value. And you should decide as a designer what that means. As a negative value, maybe the simulation should terminate, or maybe your program should crash. I don't know how you designed it. But this is the kind of a test case that students often don't think of. You always think of in terms of, well, surely I have 0 or more healthy people. That's right, you do. Or I should say you should. But in order to program defensively, what happens if something is really wrong, like having negative healthy people? We call these pathological cases. So it's a good idea to include pathological cases. And if the idea is, like, let's say you get division by 0, I have division by 0, the program should terminate. That would be a successful test, right? Program crashes. Code shall only accept positive integers or greater than 0. Positive integers greater than, that's redundant, right? Positive integers are by definition greater than 0. Code shall only accept positive integers for the zombies. That's great. So then what do? You use a test case where you set the value of the number of zombies to some positive number, and you verify that the attribute value actually has that value. And then you put in 0, and then you have to make a decision as a designer. If for some reason somebody tried to have zero zombies, what should the code do? Should it default to 1? If that's your design, then that's the test case. Inject 0 for a number of zombies, and then the code should show that the attribute value is 1. And then again, put in a negative value, and maybe for a negative value, the code resets the number of zombies to 1. This one's a little tougher. Code shall display total number of zombies. I'm wondering, can I cheat that? Always figure out if you can cheat these things. If you start this game, you start this simulation, and initially there's 100 zombies, and I put 100 on the screen, but then I never change it, have I met that requirement? That's a hard question to answer, right? So maybe that should be have a phrase at any point, at every point in time, so that if I go from 100 zombies to 98, then the code updates that. Even then, that's a tough thing to test. Anything where you're displaying things can be a tough thing to test. The way to do that, again, I wouldn't do it by necessarily do it by user interaction. You can have a test method that injects the attribute value, number of zombies is 56, and then you can visually verify you have a 56 on the screen. Or even better than visual verification, how did it get displayed on the screen? It got displayed with text, and that text entity, which is a GUI element, text is a GUI element, that text entity has a value. It would have the value 56, and you could verify that once you set the value of zombies to 56 in this class, then over here in the GUI class, that specific text value is 56, and you don't have to rely on what's on the screen. Oh, see, this one's good since start of simulation. That's good. This is why writing requirements, by the way, is never easy. Here's one. When the pause button is pressed, the game shall be paused. What do you think?
Not too great.
It's really fuzzy, yeah. So first of all, we have to define what pause means. And here's how this works. We're going to talk about animations next week. And really, you could nail this down better with when the, first of all, there's a couple things going on. So it's very fuzzy. We'll talk about animations next week. Animations do have a pause method. And so you could say when the player pauses the game, the animation is paused within one cycle. That can be measured, right? Because the animation is constantly going through a loop. So you can verify that you caught it within one cycle. Otherwise, you know, it might be paused 10 minutes later, which is not the intent. Also, it says the pause button, and there's a slight problem there because remember, don't put your design in the requirements. The requirements tell you what happens, and then the design tells you how it happens. And so when you say a pause button, what you're doing is saying you're going to have a pause button, but maybe you don't have a pause button. Some games pause when you hit the space bar. Some games pause on left mouse click. Right? So you don't embed the design in the requirement. This one is both good and bad. Clicking on the save menu item level shall save on a file with the name the user will define. Okay, there's two things going on there. First of all, there's two items in there. One is that you saved the file, and the second thing is that the user is able to define the file name. Having the user able to define a file name is a separate requirement. And then saving the file is a separate requirement. But one problem with anytime you have these saves, you get into the problem of, is the file formatted correctly? So there's actually a host of requirements here where you actually have to specify the file formatting. Because if you say you save and I save to a file and the file is complete crap and you can't use it, I technically have met that requirement. I could save an empty file and I have technically met that requirement. So unfortunately, with things like this, you can get into some real nitty-gritty problems trying to lay this stuff out. Now, if you define all this stuff ahead of time, and that's why I encourage you to define things ahead of time. If you define things ahead of time very, very clearly, you can get away with this because the only way you can meet this is you have a file in a very tightly, rigidly specified format, and then your test case would claim that. You know, here's the preconditions, here, you know, everything that the file should save, here's all their values, and then I initiate save, and then I verify that the file that is saved actually has those values in that format. Then you can get away with stuff like that. But think about how much work you have to do ahead of time to make that work. Let's see, when the program is running the racer red car, oh, that's design, right? Red car, that's design. When the program is running, the racer shall be able to move right, left when the right, left key on the keyboard are pressed. Again, there's a lot of design in there. Red car and right, left key. It probably will be right, left key, but this is not the time to lock yourself into how things are accomplished. What's really the goal here? The goal is to move left and right, which by the way is 2 requirements. One to move left, one to move right. How can I cheat this requirement? Let's say we fix all the design stuff and we say, when the program is running, which by the way, of course, when the program is running. So how about the racer? Let's just tighten it up to the racer shall be able to move to the right. Let's just do that. Can I cheat that requirement?
If he's constantly moving right and you don't really get to choose when.
Yeah. So that's one, is the car always moves to the right and it just happens to keep moving right as as the user, right? So and also then how far to the right? So every time you put in an instance of please move to the right, does it go a light year? Does it go 1/10 of a pixel? So you can specify these things. So it should be the racer shall be moved to the right. How about the racer shall be able to move to the right? Oh, yeah, that's right. So even though it's able to, if the user asks it to move to the right and it doesn't, we've still met that requirement because it's able to. We just always ignore the user inputs. So we can tighten that up to something like when the racer is commanded to move right, it shall move to the right 5 units. That kind of thing is harder to cheat.
Would putting like methods, like saying when move right method is called, it moves right 5 units, is that okay?
I think that's okay. And actually I like it because it really nails down what part of the code is going to be exercised. And then we can get into arguments about, okay, how much of the design did you put in here, you know? So again, it's a little tough, but on the other hand, you might say that instead of specifying the move right method as a specific method, you can say, I don't know, some vague term that says there shall be a move right method, right? But not naming it explicitly. The move right functionality shall cause the car to move right 5 pixels, something like that. The idea here is if you specify that the car can move right and the user commands it to move right, it moves right 5 pixels, then in the design, when you say, oh, I've got a move right method, that's where requirement traceability comes in. And you can say in your design document or in your requirements and test document, this requirement is met in class racer car method move right, which is really, I think, a cleaner way to do it. But I'm not gonna, if I take points on this, off on this, call me out on it. But I don't think I'm going to worry too much about if you declare a specific method in here. I would use a more generic name, and then you're going to create that method. Because in theory, you don't have your, again, in theory, this should not be restricting the design, right? And giving a method a specific name is a design decision. On the other hand, I like the specificity of it. So this is the kind of stuff that when you're looking at other people's requirements, which I'm going to ask you to do as a peer review exercise, that's the kind of thing to get into. And you want to be thorough, but not, you want to be a jerk without being a jerk, right? You want to be, yeah. Have you ever had a discussion with someone who just purposefully and constantly was misinterpreting what you're saying, and that was super annoying, and you knew they were doing it, but they wouldn't stop? That's the person you want to be. But in this case, you're not being annoying, you're being helpful. All right, a couple more minutes left. Let's see if we can come up with a sheepdog game requirement. Here, the that's not bad. Do you think that's bad? I don't think that's bad, but we can probably refine it. Can you come up with a way to refine that, or can you, or is it just lousy?
The increase speed method should not increase past maximum speed.
That's what I'm wondering. Maybe we can change this to specifying what we want to happen. I don't know if this is helpful or not. They're hard to write.
At what point do you put more specification into a requirement rather than splitting it up into like 3?
What are you asking? I'm not sure the question.
So like that very first one that you wrote, you could have cheated it by never having the dog move.
Oh no, but then you have another requirement. So let me keep the old one there. There is a problem with this. Hold on. How did I write it the first time? The maximum.
Dog shall not exceed its maximum speed.
Yeah, okay. The dog shall not exceed its maximum speed. Yeah, so here is one problem with it, is I wrote it as a negative, and you shouldn't write it as a negative. So we should instead can say, request to increase dog speed above or greater than the dog's maximum speed shall result in dog speed equal to the maximum. Now I've got a positive, and I've got a clear behavior that I can test. And then to get around the cheat of, okay, so one way to meet that requirement is every time I request an increase to the dog speed, then it just never does it, ever. The dog never moves. So then you can say request to increase the dog speed shall increase the current speed by 1 pixel per time unit, whatever the animation is going at. Animation cycle, that's what I want. Now, in order to meet both of these, right, if the program has to meet both of these, then I must be able to increase the dog speed. And when the dog is at maximum speed, I can't increase it anymore. But since I have to meet both of these at the same time, then I can, the only way I can cheat one is to fail the other. This is lousy language back here, but maybe I can, again, do some definitions ahead of time to talk about how the animation is going to work. And the animation is going to work in cycles, usually called ticks. And then each tick is going to have, the dog moves X pixels, basically its current speed results in, a number of pixels being moved or something like that.
Doesn't requirement 1 fail?
I'm sorry?
Doesn't requirement 1 fail because of requirement 2? Or requirement 2 fails because of 1 if it's at max speed? if it's at max speed and you
You gotta
request
go.
to increase
Yeah,
the speed?
I could say, you can put conditions in, right? When, um, you can put conditions in. And this is lousy here, because really I don't want to talk about, the pixels. I just want to talk about the model. Remember, the model view controller paradigm is in effect. So we want to talk about what happens to the model. And then we might have other requirements that talk about how the GUI represents that view of the model to the user. Okay. These are not easy. So again, don't say, okay, I'm going to set, I need to do, 5 requirements. I better set aside 10 minutes for that. No, set aside for time for that. And then come back the next day and look at them and see, oh, wait, I didn't even think about that. Show them to people. Show them to Jared. He'll find a way to cheat it. Okay. All right, we're over time, guys. I'm going to let you go. And have a wonderful weekend. And I'll start posting stuff for next week over the weekend.